Hello, 7th graders. Today we are going to be writing algebraic expressions to represent different types of situations. So we're going to be taking some words or other types of situations and then creating an algebraic expression to represent it. So the first one we're going to look at, it says write a simplified algebraic expression to represent the perimeter of the triangle. I want to remind you guys that when we talk about a simplified algebraic expression, that means there are no parentheses and no like terms. So if I was going to represent the perimeter of the triangle, the perimeter is the distance all the way around the shape. You can think of running around the shape. You can think of putting a fence post around the shape. But we want to know that total distance all the way around the shape. So what I'm going to be doing is I'm going to be adding up all of my sides. So if I look at my sides, I have 5x minus 2 is one side, plus another side is 2x plus 5, and then that last side is 3x. So when we look here, I have my 3 side lengths included. All right. Now, this would be an algebraic expression to represent the perimeter of the triangle, but we want to make it a simplified algebraic expression. So again, we have no parentheses, and then we need no like terms. I don't have any parentheses, but I do have like terms. So I'm going to go ahead and combine those. So when I look at this, I see a positive 5x, a positive 2x, and a positive 3x. And so if I combine those all together, 5x plus 2x is 7x plus 3x gives me 10x. And then I see some constants here too. I see negative 2 and positive 5. So negative 2 plus 5 would be positive 3. Because it's positive, I can write that as a plus sign. And so my simplified algebraic expression would be 10x plus 3. And number 2, write a simplified algebraic expression to represent the perimeter of the rectangle. Again, the perimeter is going to be the distance all the way around our shape. Because this is a rectangle, I'm given 2 sides, but if the bottom length is 3x, then that means the top length is 3x. And if my right side is x, then my left side is also x. So if I want to add up all of my sides, I'm going to have 3x plus x plus 3x plus x. Some of you might also do something like 3x plus x and multiply that by 2. That would be another way that you could think of this problem. So when I see these x's by themselves without a coefficient, remember we have an invisible coefficient of 1 in front of them. And so when I combine all of my like terms that I have here, these are all x terms, so I can simplify them by adding them all up. I'm going to end up with 3x plus 1x is 4x, plus another 3x is 7x, plus 1x is going to give me 8x. Okay. You could also think of distributing and getting 6x plus 2x, and then that would also give you 8x here. All right, number 3, a group of friends go to the movie theater together. They know the following cost. A movie ticket is $7, a drink is $3, and popcorn is $4.50. They each purchase a movie ticket, a drink, and a popcorn. Write a simplified algebraic expression that represents the total cost for n number of people. So every person is going to be buying a movie ticket, their drink, and their popcorn. So the movie ticket is $7, the drink is $3, and their popcorn is $4.50. So every single person is going to spend that amount, and we want to know the cost for n number of people. So we're going to be multiplying that total cost times n, okay? If we think back to a simplified algebraic expression, no parentheses, no like terms. Well, within these parentheses, these are all like terms, so I could go ahead and combine for that total cost. So $7 plus $3 is $10, plus the $4.50 would be $14.50. All right, and then I'm multiplying that times n. And then remember, we can also express multiplication by just having a coefficient followed by that variable like that. So this would be 14.50n. You could also write that as 14.5n. You and your dad are going to an amusement park. The admission price is $20 for adults and $12 for children under 16. Once inside the park, the price for each ride is $4 for adults and $2.50 for children under 16. Write a simplified algebraic expression to represent how much it would cost you and your dad to ride our rides together. So we don't know how many rides we're riding, okay? It might be 2 rides, it might be 5 rides, it could be 20 rides. That's what R is going to represent. So when we look at this, this one has some different components to it. Just to even get in to our amusement park, your dad has to pay $20 and then $12 for you. So we for sure have to pay the $20 and the $12. So just even right now, we could go ahead and we could combine those. So right now, we're paying $32 for us to get into the amusement park. Once we're inside the park, every ride, your dad is going to pay $4 for and $2.50 for you. So one ride, $4 for him, $2.50 for you. Okay, so that would be a total of $6.50. But that $6.50, like for 2 rides, then we would multiply that by 2. If it was 3 rides, we would multiply that by 3. So we're multiplying this times our number of rides, which right now is R. And so we could write this as the $32 that you have to pay. That's the constant, okay? That's not going to change. Plus that $6.50 per ride. And again, the $6.50 is the combined total of the cost for each ride. You could also think of this as 4R and $2.50 R. So this would be our simplified algebraic expression. Typically, we would write our variables first, but either one of those would be acceptable. All right, you go to the pumpkin patch. It costs $20 to get into the pumpkin patch, plus $9 per pumpkin that you buy. Write a simplified algebraic expression to represent how much it will cost you to spend a day at the pumpkin patch buying P number of pumpkins. So again, this time, you have to pay that $20 to get in, okay? You could go to the pumpkin patch and not buy any pumpkins, and you still spend $20. In addition to the $20, you're spending $9 per pumpkin that you buy, and we want to know how much you're spending to buy P number of pumpkins. So we've already spent $20, but now we want to think, how can we represent that $9 per pumpkin? Well, if P is the number of pumpkins, we can represent that by 9P. So 9P is representing $9 per pumpkin. This is a rate. And so we have 9P plus 20 would be our simplified algebraic expression. Have a great day.